A strike from a crocodile occurs with a speed defying its 1,000-pound weight. This movement is the result of millions of years of anatomical refinement. Every organ and every tooth is part of a specialized system. One strategy relies on the physical properties of water and kinetic energy. Another, used by snakes, functions through biochemical interference. The specialized nature of these biological systems creates specific vulnerabilities that determine who survives a confrontation. Success in the wild depends on how effectively a predator applies the forces of mass, chemistry, and geometry against its opponent. To remain submerged, a crocodile has to overcome its own anatomy. Its large, air-filled lungs provide significant lift, naturally pulling the animal toward the surface. They compensate for this lift by carrying stones in their digestive tract. These rocks act as ballast, providing the dense weight needed to counter the buoyancy of the lungs and allowing the crocodile to hang suspended. This ballast keeps their eyes and nostrils level with the waterline. Because light refracts as it passes from the air into the water, it creates a visual field known as Snell's window. This 97-degree view allows the crocodile to see the bank clearly, while its submerged body remains obscured by the bending light. When the ambush is triggered, the crocodile's conical teeth serve as hooks. They are efficient at gripping prey, but they cannot slice through tissue. To tear meat into manageable pieces, the crocodile tucks its legs against its torso to reduce its radius. By shrinking its profile, it increases its rotational speed. The force of the spin generates enough torque to separate bone and muscle. The crocodile maintains its position at the top of the food chain by managing its density and angular momentum. Snakes bypass the need for physical force entirely. They operate with minimal mass, using specialized chemistry to disable prey. Species like the king cobra use neurotoxins. As shown in this diagram of a nerve synapse, the venom molecules are shaped to lock into muscle receptors, preventing electrical signals from reaching the tissue. The effect is a sequential shutdown. It begins with the eyelids and facial muscles, eventually moving through the limbs until the muscles responsible for breathing stop responding. Vipers take a different chemical path, using enzymes designed to break down the structure of the body itself. These proteins prevent blood from clotting and rupture the walls of the vascular system. Solid tissues lose their integrity and begin to liquefy. These chemical tools systematically dismantle a victim's biological infrastructure from within. Specialization creates a point of failure. A strategy built on physical force struggles against an opponent designed to absorb it. A 6,000-pound hippo has a hide nearly 1.5 inches thick. Its sheer weight and resilient skin make the torque of a death roll ineffective. A jaguar avoids the heavy back armor entirely. It targets a specific, unarmored gap just behind the skull plate, driving its teeth through to sever the spinal cord directly. The anaconda's musculature is flexible enough to absorb blunt impact. It uses its body as leverage, wrapping its coils around the crocodile to compress the rib cage and prevent the lungs from expanding. Even the most effective biological systems fail when confronted with an opponent designed to exploit their specific anatomical gaps. The animal kingdom functions through a hierarchy of physical and chemical advantages. Mass and momentum defeat standard defenses. Precision anatomy can bypass heavy armor, and biochemistry ignores physical strength entirely. A crocodile maintains its position by regulating its density. A snake delivers a payload of specialized enzymes. Nature is a cycle of refinement. No matter how effective a biological system is, another is constantly evolving to exploit its flaws.